All right, we're going to look through the Unit D review. Hopefully you have looked and tried those problems. If not, you can hop off here and work on those. Otherwise, I'll pull the document camera up and we will get going through them. All right. So here we have find x and all angles. Okay, so they give us this exterior angle and the opposite two interior angles. So this angle equals the sum of those two angles. So equals x plus 20. Okay, so now all I need to do here is solve for x. Okay, so if we're going to subtract x, those cancel. We're going to add 25. So those cancel. So you get 2x minus x is x equals 20 plus 25 is 45. So x is 45. Now, if I want to find the angles here, this angle is just x, so that's 45 degrees. And if I add these two up, I get this angle. So this angle is 65 degrees. Well, not percent, just degrees. Okay, here number 2, find x and all angles. So again, this exterior angle, x equals the sum of the two opposite interior angles. So 2x plus 90. So we're going to subtract 2x. 8x minus 2x is 6x equals 90. And then 90 divided by 6, x is 15. Okay, so this is 90. 2x is 15 times 2, which is 30. And then 90 plus 30 is 120. So that's 120 degrees. Here we want to find x. Okay. So all the interior angles add up to 180. So I have 90. I have this angle, which this one and this one are the same. So it's 35. And then I have 5x. So if I add those together, so you have 35 plus 90 plus 5x, it will equal 180 degrees. So 35 plus 90 is 125 plus 5x equals 180. You're going to subtract the 125. 5x equals 180 minus 125 is 55. And divide everything by 5, you get x to be 11. Okay, tell if true or false and why. So is triangle XYZ congruent to triangle RST? So it looks like I got sides congruent. Now just look at the letters. Okay, XY, XY, RS. So XY has 1, RS has 1. YZ has 2, ST should have 2. Remember, the order matters. And XZRT 3, 3. So yes, it is true because of side, side, side. Okay, side, side, side. Again, you have your list of reasons, which I'm going to go through here in just a little bit, has what you can use on it. Okay. Okay, so here it's saying that triangle ABC is congruent to triangle DCB. They share this side here, which would be congruent. Okay, then you got 4, 8, 10, 8 and 8, but you have a 4 and a 5. So those sides aren't congruent. So this is false. sides are not congruent. Oh, here was another one from this top one here. Find x and angles. Okay, so again, we're taking all three angles and add them up and set them equal to 180. Okay, so you got x, x, and x. So 7, 8, 9, 10, 11x minus 10 equals 180. Add 10. 11x equals 190. Divide everything by 11. And you get 17.27. Okay, so then I take that and plug it into all of these to find the angles. So this one is 17.27. This one is 7 times 17.27, which is 120.89. And you do have a calculator on the test that you can access. I believe it's in the left, like the top left area. And then we have 3 times 17.27 minus 10. So 3 times 17.27 minus 10. This one is 41.81. Okay. All right, here in number 5, give congruent triangles and why. Okay, so they give us some shapes here, and they want us to say if the triangles are congruent. Okay, so I have this side and this side and this side and this side. So then these angles are also congruent because they're vertical. Okay, and then I have a side angle side, which if we look right here, side angle side, so they're congruent. Okay, so we could say triangle QSR congruent. Now, since these both have it, I don't know if this was a reflection or a rotation, so I can choose. I'm just going to choose a reflection, so TSQ. And that was side angle side. Okay, here you have this angle is 90, this side, and this side. So that would be an angle side side, and we don't have an angle side side on this sheet, or a side side angle on this sheet. Okay, so I cannot prove, and I can't prove anything else. You got 2 sides. I can't prove the third one. There's the third angles theorem, but there's not a third side theorem. So this is triangles not congruent. Okay, because you'd have angle side side. Okay, so say what on number 6, they give you these 2 triangles over here. Say what is missing. So if I want to use angle side, they give me these 2, and I need to find the third thing. Okay, so they give me a side, and they give me this angle. So they give me, let's say they give me angle D inside DE. Okay, so angle side, or side angle I need side angle, and then I need this angle over here. So angle F congruent. Okay, so angle G inside GH. So GHG. So I need angle side. So angle J. Okay, so then you could erase that off there so you don't get confused on the next one. Okay, so for angle side angle, DF, so DF and GJ, and angle F and angle J. And you need angle side angle, so the side's in between 2 angles. So you need angle D to be congruent to angle G. Okay, here and here. So angle side angle. Again, we'll erase it. You want to use side angle side. So JH congruent to FE, HG congruent to ED, and you want side angle side, so you need the angle in between them. So that's angle E congruent to angle H. Okay, and the last one here, you want side, side, side. So you want DE, and GH. You want EF and HJ. So the last one would be DF congruent. So DF congruent to GJ for your side, side, side. Okay. Flip it over. We've got some more. Okay, so prove that angle 1 is congruent to angle 2. Okay, so we're just going to set up statements and reasons here. Okay, and given is your first reason. And looking at this picture, what are we given? So we're given that KH is congruent to GH. We're also given that angle K and angle G are right angles. And that's all we're given. And we're trying to prove that these two angles up here are congruent. In order to do that, I need to prove that the triangles are congruent. Well, we see here that we share a side. So FH is congruent to FH. That is the reflexive property. And I have right angles, so that means I have right triangles. So triangle HKF and triangle HGF are right triangles. That is definition of a right triangle. Definition of a right triangle says if a triangle has a right angle, then it's a right triangle. So here I have the hypotenuse and the leg congruent. So therefore my two triangles have to be congruent. That is HL. Now, because my two triangles are congruent, every single part in the triangle has to be congruent. So now angle 1 has to be congruent to angle 2, and that is CPCTC. Okay, corresponding parts of congruent triangles are congruent. Okay, so we had to prove that the triangles are congruent first. Number 8, find the value of x. Okay, so you have these two angles are the same. Therefore, the sides opposite have to be the same. So 7x plus 5 equals 13 minus x. Okay, that's the base angles theorem. So we're going to subtract 5 and add x. So those cancel and those cancel. You get 8x equals 13 minus 5 is 8. So divide by 8, x equals 1. Okay, and it didn't want me to find the side, so I don't need to. Find the distance and midpoint. We're not going to do that. We haven't talked about that, so we're going to skip that. Here are some older stuff here from previous units. Show that 1 is congruent to 7. So here's angle 1, and 17 is right here. So angle 1 is congruent to, let's say, angle 6. right here. Those are alternate exterior angles. And angle 6 congruent to angle 8. Those are corresponding. Dang it. 8 is congruent to 11. Those are alternate interior. 11 to 12. Those are vertical. 12 to 14. Those are corresponding. And then we have 14 to 17. Those are alternate interior. And then the last one, we have angle 1. Man, this lead is not good. Angle 1 congruent to angle 17 is the transitive property. Okay, so just make your way through it. Try to use a variety of angles. All right, number 11 here. Find x and length. So xy is 5. YZ is x plus 3. And xz is 2x minus 10. So if we take the two parts and add them, they will equal the whole thing. Okay, so you have 5 plus 3 is 8, so you have x plus 8 equals 2x minus 10.
Okay, I found this.
We're going to subtract x plus 10. Those cancel. Those canceled. So 8 that's a plus 10. So 8 plus 10 is 18 equals x. So x is 18. So that means that this length right here is 18 plus 3, which is 21. And then this one is 21 plus 5. Add those two together, you get 26. All right, number 12. Find x and y. So we've got parallel lines in our transversal. So let's figure out x. So I've got this angle here and this angle here. Those are alternate exterior, and alternate exterior angles are congruent. So you have 2x minus 3 equals x plus 3. So we're going to add 3 and subtract x. So x equals 6. Okay, now these two angles add up to 180. Okay, so I'm going to take 6 and plug it in here. So 2 times 6 is 12. 12 minus 3 is 9. Okay, so if I take 9 plus this, it'll equal this straight line of 180 degrees. So 9 plus 4y minus 5 equals 180. Okay, so 9 minus 5 is 4. So 4x plus 4 equals 180. Subtract 4. 4x equals 176. And divide everything by 4. 176 divided by 4 is 44. Oh, and that is y, not x. Y is 44. X was 6. Okay, so there's that part. And then we have a few examples. We've got 6 examples of proofs. But before we go through those, I want to kind of go through some of these that we've on the valid list of reasons page. So SSS is side, side, side. SAS is side, angle, side. ASA is angle, side, angle. AAS would be angle, angle, side. HL only on right triangles, that is hypotenuse, leg. CPCTC corresponding parts of congruent triangles are congruent. We haven't got to the similarity stuff. That'll be next semester. Triangle sum theorem. Interior angles equal, well, we'll put sum to 180. Base angle theorem. That was the one where the two angles are the same, then the sides opposite the angles are the same. Sides opposite. Base angles are congruent. Converse base angle theorem. So that's the reverse of this. So that says that your angles opposite the sides are congruent. Angles opposite two congruent sides are congruent. Exterior angle theorem. Exterior angle sums to the two opposite interior angles. Third angles theorem. Third angles theorem says if two angles are congruent in two different triangles, then the third angles are congruent. The right angle theorem says that all right angles are congruent. Congruent supplement angle theorem and congruent complement angle theorem are the same. It says two angles and this goes for both. The only word difference would be supplement and complement. So two angles supplement to the same angle are congruent, and two angles complement to the same angle are congruent. Okay, and that's kind of the additional stuff that we had this go around that you can put on there. So now we're going to look through some of these proofs. Here, I'll switch to a pen. Okay, so here's my picture. They don't list out a given, but we'll put in the given. We're given that angle Z is congruent to angle X. And we're also given that VW is congruent to UW. And I'm trying to prove that XWV, so this triangle, notice I got an angle and a side, is congruent to this triangle. So statements, reasons, Okay, we'll copy down our given, angle Z congruent to angle X, VW congruent to UW, that is given. Okay, now we look for something that is shared. These two triangles here share this angle W. So angle XWV is congruent to angle ZWU. That's this angle right here. And it's shared, so that is your reflexive property. Okay, so now we got this angle. So you have an angle, and a side. An angle, and a side. So that proves that is on my list. Angle, side. That is on my list. So these two triangles can be congruent now. So I just copy what's there, angle, side, and I'm done. Okay. Moving over here. So statements, reasons. Okay, T is midpoint of PR segment and SQ segment. That's given. Okay, we're trying to prove it. These two angles are congruent. So in order to do that, I need to prove that these triangles they're in are congruent. So T is the midpoint of these two. Okay, and what the midpoint does is it splits the segment in half. So this one and this one is the same. So PT segment has to be congruent to RT segment. And it also splits this one. Now, I don't know that those two segments are the same. So I'm going to say that this one is different than the other two. So ST has to be congruent to QT. That is by definition of midpoint, because that's what we used. We said a midpoint splits it into two equal halves. So you got two sides. And then you have these two angles right here. So angle PTS is congruent to angle RTQ, because those are vertical angles. Okay, so now you have side, angle, side. So your triangles have to be congruent. That was side, angle, side. And now because those two triangles are congruent, every single part in those two triangles are congruent. So you have angle 1 congruent to angle 2 now, CPCTC. Again, that's not the only way you could have gone through that. You could have gone through proving that these two sides are parallel, and then those are alternate interior angles. But you don't, that may be a harder way of doing the proof, but you don't have to always do it the same way. Okay, they don't give us any given, so we'll look here and look at the given. So it looks like segment A, B, and DE are parallel. So AB segment parallel to DE segment. And when I see parallel lines, I should be thinking those angle pairs. So corresponding, alternate interior, alternate exterior, all those. And we also have the AC is congruent to EC. So statements, reasons, given. So AB parallel to DE, AC congruent to EC. Okay. We have vertical angles right here. So this angle and this angle are vertical. So angle ACB is congruent to angle ECD. The vertical angles. There's nothing shared in these two triangles. And we can go with one of two angles. See, I have parallel lines and I have actually two transversals. So it doesn't really matter which angle you go with. for alternate interior. But just go with one of them. I'm going to go with this one and this one. So angle CAB congruent to angle CED. And those are alternate interior angles. You could have gone with this angle and this angle as well. So here you have an angle side angle. So their triangles are congruent, CAB congruent to triangle CED. But I want two parts. So now since the triangles are congruent, I can talk about the parts being congruent, DC by CPCTC. And we're done. So there's only a few steps on each one of these that may be a little difficult, and they'll get longer as we go through. Okay, so statements, reasons. Okay, so angle ACD congruent to angle ADC, angle BAC congruent to angle EAD. Okay, that's given. All right, so let's label those on our picture. So ACD, so this angle, and ADC, this angle. Okay, so something I already noticed, I have these two base angles, so the sides opposite automatically have to be the same. Now, I can look at this little triangle, or I can look at this bigger triangle to get those sides. So actually, I can use the base angle theorem to say that these two sides are the same and those two sides. So angle BAC, so this angle, and angle EAD, this angle are the same. And I'm trying to prove, I like to sometimes go with a different color to look at what I'm proving. ABC, so this triangle congruent to AED, this triangle. Okay, so let's start with the base angle theorem. We can go from these two angles are the same, so the sides opposite, so this side and this side are the same. Okay, and I'm going to use some other reasons that we haven't quite used before. So I will say that we'll just go right here. So AC and AD are the same. So AC is congruent to AD. That is the base angles theorem. So here and here. Okay. So you have an angle and a side. Now look, I got this angle down here, which lies on a line. Okay, so this angle and this angle are a linear pair, but they are also supplementary. Okay, so we could say that angle ACB and angle ACD, and then go to the other pair. So angle ADE and angle ADC are a linear pair. Definition of linear pair. And I'll just put in here also, because they're a linear pair, they're supplementary and supplementary. Okay, so this angle, because these two are equal, these two are supplementary to those two, so they're also equal. And I'm kind of running out of room here, but angle ACB is congruent to angle ADE, and that is the congruent supplement angle theorem. Okay, because these two angles out here are supplementary to the same angle. So 1, 2, 3, 1, 2, 3. Okay, and you have angle, side, angle, and I'm out of room, so I'm going to go up here. So triangle ABC is congruent to triangle AED. And that is angle, side, angle, angle, side, angle. And you're done. Kind of a longer one. There's a different way you could have done it. You could have used side, angle, side there as well. But yeah. All right. So here, actually, I'm going to kind of go up so I can write on this paper. Okay, so statements, reasons. Okay, so rewrite all that. So triangle ABC is isosceles with base AC. Segment BD bisects angle B. Okay, so ABC, here's the base. Okay, so I have these two angles are congruent. Okay, so we'll say that angle A is congruent to angle C. Definition of isosceles triangle. Okay, now I know because of that, we could say that the sides opposite are the same. Okay, we can use this bisects part. I've got this here is shared. We want angle BDA. BDA is congruent to this angle right here. So these two angles need to be congruent. Therefore, these two triangles have to be the same. So let's use the fact that BD bisects angle B. So this right here bisects this angle. So this angle has to be the same as this angle. Okay. So angle ABD is congruent to angle CBD. And that was definition of bisect. Okay. Now I just noticed this, we don't have to prove that the triangles are congruent. Okay, because if you have two angles of one triangle are congruent to two angles of another one, then the third angle has to be congruent. So I can say angle BDA is congruent to angle BDC. And because I've already said it's an isosceles triangle up here, okay, by third angles theorem. Otherwise, you could say that you've got reflexive here, and you have angle, angle, side, and then you use CP, CTC. But in this one, it kind of led to itself that you don't need to prove the triangles are congruent. Okay, here we are on the last one, which will kind of be a long one here. So statements, reasons. Okay, D is a midpoint of AC. So D is midpoint of AC. That is given. Okay, since D is the midpoint of AC, right here. I forgot that part. And BD is perpendicular to AC. Okay, all that's given. Since D is the midpoint of AC, this and this are the same. Okay, so AD is congruent to CD. That is definition of midpoint. Okay. I have here BD D. So BD is congruent to BD, that is reflexive. Okay, and now they're perpendicular, but I have to say that they're right angles and that the right angles are congruent. So angle BDC and angle BDA are right angles. That is definition of perpendicular. Okay, now those two are right angles, but they're also congruent. So angle BDC congruent to angle BDA, and that is the right angle theorem, which we're just talking about. That just says all right angles are the same. Oh, sorry, you couldn't see that. So then these two are right angles and they're the same. You have side angle side. So you have triangle ABD congruent to triangle CBD. That was side angle side. And you're trying to prove that these two sides are congruent, which I can now. AB is congruent to CB. That is CPCTC. Okay, so these two triangles are congruent. Therefore, this side and all the other parts are congruent. Okay, so that sums it up for the Unit D review. If you have any questions, please reach out and ask me. And you should be now ready for the test. Again, if you got questions, please let me know.